So now let's see what we can do with these quadratic functions, especially once we have it converted to that standard form. So here I have the quadratic in the other form, and I can easily pick out that a is 2, b is negative 12, and c is 23. And what I'm going to do first is I'm going to go get the standard form of this. So if you remember, that's just ax minus h squared plus k. And I know that I can get h as negative b over 2a. In other words, negative 12 over 2 times 2. So that gives me 12 over 4 or 3. And then I could use that to let me get k as just f of h, or in other words, just f of 3. So if I plug 3 in, 2 times 3 squared minus 12 times 3 plus 23 would give me 5. Okay. And then I can just plug those numbers in. So a was 2, and then x minus h, so x minus 3 squared plus k is 5. Okay, so there, and this will allow me to get the next piece of information very easily. The axis and the vertex. Well, the axis was just x equals that h value, so that would just be x equals 3. And the vertex is just the point h comma k. And so I found previously that that was 3, 5. Got it. Okay, as far as the intercepts, that's just like what we've looked before. If we want the y-intercept, we just let x be 0. All right, and then I can use whatever form I want. So if I want to go back to this original form here, I can do that. That would be f of 0. So that would be 0 minus 0 plus 23. And that would just give me a y-intercept of 23. For the x-intercepts, of course, I want let y equal 0. And again, I'm going to use that original form and just say that this means that 2x squared minus 12x plus 23 is 0. Okay, so now lots of different ways I can solve this. I can go ahead and use a quadratic formula. So x is negative b, so positive 12 plus or minus the square root of b squared, which is 144, minus 4. A is 2 and c is 23 over 2a, which is 2 times 2. Okay, so now if I look inside here, remember that all-important b squared minus 4ac ends up inside there being 144 minus 184. But that's negative 40, which is less than 0. Which means I have no real solutions. They would be imaginary. All right, so that means that I have no x-intercepts, which is perfectly fine for a parabola because it could be sitting above or below the x-axis. So that's a good piece of information. Now I should be able to pretty easily sketch this with the information I have. And I don't need a great sketch, I just need something that has the information captured in it. Okay, so this x and y, we found that our all-important vertex above was 3, 5. So 1, 2, 3, let's go 1, 2, 3, 4, 5. Okay, is there. So there's our vertex of 3, 5. We did find a y-intercept of 23. Now, I don't need this to be super accurate, so I'm just going to call that 23 up there, although from the scaling it doesn't look like it. That's okay, though. All right, so there's my vertex. I also know that the a, being 2, was positive, so it's facing upward. So I pretty much know that I just have this parabola, just like this. Okay, And there's a sketch of my parabola. I get the basic idea of what it looks like. So now, from especially using that, I can get some more information. What are the maximum and minimum values? All right, maximum value and minimum value. We'll realize that a parabola is only going to have one of these. It either has a bottom, a minimum value like we see here, or if it was facing downward, it would have a maximum value. So it can only have one of these. So this one does not have a maximum value because it keeps going on up forever. And its minimum value is just the value right here, the y value of the vertex. So 5. That wasn't so bad once we had this, all the work we'd done before it. The range as well is going to be pretty easy from this. Again, if we're looking at the range, work your way up in y values. The first y value we're going to get, well, that's just going to be the y value of the vertex. And we're going to get that, so we have 5, comma, keeps going up to infinity. That's it. Let's do another one. All right. Again, so here's my form before. I'll just identify a is -1, b is 1, c is 2. We're looking for f of x is a, x minus h squared plus k. H is your negative b over 2a. So -1 over 2 times -1, or positive 1/2. K is then f of h, or f of 1/2. So I would plug that in, so -1/2 squared plus 1/2 plus 2. Work that out, you're going to get 9/4. So we know that f of x is a, which is -1, x minus 1/2 squared, because the h was 1/2, plus 9/4. Good. The axis and the vertex. Okay. Again, the axis, that's just x equals h, so x equals 1/2. The vertex, that's just hk. So 1/2, 9/4. All right. Y-intercept, that's when x is 0. So if I put 0 in there, I get 0 plus 0 plus 2. So my y-intercept is 2. If I do x-intercept, I would do y equals 0. That would give me -x squared plus x plus 2 equals 0. And if I multiply through by a negative, make it a little nicer, x squared minus x minus 2 equals 0, I could factor that. And that's going to give me -2 and plus 1 to give me the -2x and plus 1x to give me the -x in there. And that says that x would be 2 and x would be -1 to solve that. And then those would be my x-intercepts. All right, I should be able to sketch it pretty easily. All right, so let's say I do have to do, let's see, 1, 2, 3. All right, so, and let's go out there for 1, 2, 3. All right, so 1/2, 9/4. So 9/4 is 2 1/4. So we'll go a little above 2 there. And we know we have the y-intercept at 2. And we actually know we have x-intercepts at -1 and 2 from right above there. And so we have here and here. And so everything is pretty much giving us the general shape of this thing. And in fact, we know that since a was negative, this is facing downward, which agrees with everything that we see here. So that and that. And there we go. All right, so that has given us a nice picture of this parabola, a nice little sketch. And again, if we're looking for the max and min values, remember this could only have one of these two. This time, because it's facing down, the vertex is the maximum value. So the maximum value is the y value there, 9/4. And there's no minimum value because this thing keeps going down forever. And the graph also tells us the range quite easily. Remember, we're going to head up from negative infinity. And so since it goes on forever, we start at negative infinity, where it's open, and go up to our maximum value. Again, is that value at the y coordinate of the vertex, which is 9/4, and we do get it. And that's it. So there we've been able to analyze the quadratic function quite nicely with all this information, the standard form, the vertex, and it is quite nice dealing with the quadratic function in this way.